If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys and gals, let's talk about variables. Now a variable is a placeholder for a value, and it behaves as the value that it contains. Do you remember from either elementary school or middle school when we were working with algebra, we usually had to solve for some sort of variable like x or y, and x or y contained some sort of numeric value, and for all intents and purposes, this variable behaved exactly as this value. Well, with programming, we can perform something similar to that, but we are not limited to just numbers. We could also store words, whole sentences, and these things called Boolean values, which hold either true or false. But if we're going to store a value within a variable, we have to list the data type of what we're planning to store within that variable. Is it going to be a number, a word, a Boolean? So we need to discuss data types. There are 8 primitive data types and a special reference data type called a string. Anything that I have noted with a star is particularly important, so I would pay special attention to these. Our first data type is Boolean. This has a size of 1 bit, so it can only hold 2 values, that being true or false. If we're attempting to assign a Boolean value, we would type either equals true or equals false. Something similar would be, let's say we have a light switch program. Well, if the light switch is on, we could say that the light switch has a value of true. If it's off, it has a value of false. So this is binary. That's why it only uses 1 bit. It only needs 1 bit of memory to function. Next, we have byte. This isn't as important as a few others, but with 1 byte, we can hold an integer number between -128 to 127 because a byte only has 1 byte of memory. A short has 2 bytes of memory, so it can hold a larger number between -32,000 and some change to 32,000 and some change. So integers are important. These use 4 bytes of memory, and they can store a number to just under 2 billion to just over 2 billion because they use 4 bytes of memory. And a long, they use 8 bytes of memory, so they can hold a very large number. In fact, they can hold a number between just under -9 quintillion to just over +9 quintillion. Now a float, they can store a fractional number, specifically up to 6 to 7 digits. What makes floats different from these data types on the top here is that bytes, shorts, integers, and longs can only store a whole integer. They cannot store this decimal portion. So if you're working with a program or a variable that uses a fractional number, you'll need to use either a float or a double. And a double has more precision. It uses 8 bytes of memory, and it can store a fractional number up to 15 digits. So in comparison with a float, this has less precision than a double. And for an example, I just listed a few of the digits of pi. With this example, we can only store 6 to 7 digits of pi, but with a double, we can store up to 15. There is one strange convention with floats. If you're going to assign a value to a variable that's of the float data type, you need to follow the value with the letter F. With double variables, you actually do not need to do so. So that's one major difference when assigning values between these two. Now let's move on to characters, pronounced char for short. Think of Charizard. This uses 2 bytes of memory, and this will store a single character letter or ASCII value. An example would be the letter F, but a common convention with assigning values to a char variable is that you need to surround this value with a pair of single quotes. And our last data type is the string data type. The size really varies because these are reference data types. They store a sequence of characters like a word or a sentence. You could store a single character within a string, but chars and strings behave differently because chars are primitive data types and strings are reference data types. So let's distinguish the difference between primitive and reference data types. Here's a super quick description between the differences of primitive and reference data types. Primitive data types, there are 8, and we just discussed them. They are Boolean, byte, short, integer, or longs, all those cool things that we just discussed. Reference data types, like strings, well, there's an unlimited amount because they are user-defined. Primitives store data. Reference data types store an address. Primitives can only hold one value. Reference data types could hold more than one value. Primitives use less memory compared to reference data types, which use more memory. And primitive data types are faster compared to reference data types, which are slower. Now you're probably thinking, cool story, bro, but how do we create a variable? Well, I'm glad you asked that question. So the first process with creating a variable is that we need to declare the data type of what value that this variable is going to store. So come up with a variable name like x, and we will precede this variable with the data type of the value that we're planning to store within this variable. And then with all statements, we follow this with a semicolon at the end. The next step is called assignment. We will take our variable and assign it equal to some sort of value of the data type that we declared this variable to be. But you could combine steps 1 and 2 together, and this process is called initialization. We would take the data type followed by the variable name and set it equal to some value, and then add a semicolon at the end to finish the statement. So you can either do this in 2 steps with declaration and assignment, or combine them both together, which is initialization.
Hey there, do you want to make a 6-figure salary as a Python developer? Well, guess what?
How about we create a few variables? Does that sound good to you guys? So let's begin with creating an integer variable. Let's say int x. This step is called declaration. We are declaring the data type of what value is going to be contained within this variable. The second step is called assignment. We can assign our variable a value. Let's say x equals 123, and this step is called assignment. Or we could combine both of these steps together, and this process is called initialization. Int x equals 123, and this would be initialization. So we can do stuff with this variable. It will behave as the value that it contains. We could print this to the console window, so within a print or print line statement, we could print the value of x. So make sure you do not write this within in quotes. Right now, this will display the value that is contained within x, which is 123, because this variable behaves as the value that it contains. If you were to surround this with quotes, what we are doing now is printing a string literal. You can also print text as well as a variable together. Let's say we have a sentence, a string literal that states my number is, and then if we want to do some string concatenation with a variable, we would add plus and then the variable name. Make sure this is not within quotes. So this will display the sentence my number is plus our variable, and in the console window it states my number is 123. So with integer variables, the largest number that you can store within an integer variable is just over 2 billion. Let's say we are working with an extremely large number, like the amount of student debt that I owe. Well, this number is too large to store within an integer variable. We would probably want to use the long data type. And one convention with assigning values to a long variable is that you need to follow this number with a capital L for some reason. So we can now work with extremely large numbers. So this might be useful if you're working with numbers like the speed of light or something. So we now have a long variable and we can display this value. A few of the other data types that we mentioned were bytes and shorts. They have a lesser number that they can store. So with bytes, you can only store up to, I believe, 127. So we could store like 100 within here, and this would be fine, but one 30 would be a little too much though. So we don't tend to use bytes and shorts too much as a beginner because it's just way more convenient to work with integers. But you might use longs every once in a while too. But as beginners, we're mostly going to be sticking with integers. Now a double can store a number with a fractional portion. With integers, we cannot store a decimal portion. So if this was 123.01, well, we cannot store this decimal portion. We can only do so with a float or a double. So with a float, you would type in float for the data type. Let's create a new variable like y. Float y equals 3.14. And a common convention for assigning numbers, well, values to float variables is that you have to follow this with f. So you can store a number with a decimal portion within a float or a double, and then we could display whatever this value is. So y is equal to 3.14, but people tend to use doubles more because they have more precision, and then you do not need this f at the end. So this will store up to 15 digits after the decimal portion. So we also have booleans. Let's say boolean z equals, this holds either true or false. And then we can display what value is within this boolean. So if we print our variable z, this will display false.
Where is it? Oh, whoops. Then add z plus z. Nice.
Or we could hold true, and this will display true, but we can't display anything else besides those two. Like we cannot hold the word pizza because booleans only hold true or false. We have characters, char for short, char, and we don't necessarily need to come up with a variable that's only one letter. We could have a name or something that's descriptive for this. Let's say we have a variable called symbol. Char symbol equals, and then place a character within single quotes. Let's say we want the @ sign. So we now have a variable called symbol that contains the @ sign. So if I were to display this variable symbol to the console window, it will display the value that is contained within, which is the @ sign. And lastly, we have strings. So with strings, these start with a capital S because
Hold on. Got that. Nice.
they are of the reference data type. Anything that's a reference data type begins with a capital letter. And let's say we want to store our name. So string is the data type. Let's say the variable name is name equals, and to store a string, it works similar to a string literal. We're going to use a set of double quotes and display or add a bunch of text like my name. And then I can now display my name to the console window, or I could do some string concatenation too and display the word hello plus my name. And within the console window, it's now going to display hello, bro. So that is everything you need to know to get started with variables in Java. If you would like a copy of all this code, I will post all of this in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow.
Did you know you can AFK Bloods and Zaya whilst learning to code in Python? Go to boot.dev. We've known our students to pull it off. Here's how. Monitor 1.
Hello, bro. How's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can swap two variables using Java.
Gotta create a new. Perfect. I don't even know, bro. This is slow as heck. Ugh.
Let's get into it.
Oh,
If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, well here we got two variables. We got variable X, which contains water, and variable Y, which I'm gonna put Kool-Aid in. More specifically, black cherry Kool-Aid. So let's just put this in. Good enough.
where the hell is? Okay, here it is. Okay.
Enough. And let's mix it. Perfect. So we're going to create two variables, and these are going to be of the string data type. So we'll have string X.
I don't even know how to zoom in this. Whatever. I'm gonna play it as is.
Equals the word water. And string y equals the word Kool-Aid. And then let's display these with a simple print line statement. And within here, I'll just type in x colon space plus the variable x. And then let's do the same thing for y. So we'll change x to y. And let's display these. So x currently has water, and y currently has Kool-Aid. So what happens if we set x to equal y? Well, we get Kool-Aid for both x and y. Okay, we're going to assign variable y to variable x. Shit. So yeah, it looks like we have Kool-Aid in both variable x and variable y. Let's try again. Maybe we can set y to equal x. No, we just got water everywhere. Let's try this again. We're going to assign variable x to variable y this time. Okay, that doesn't seem to work. Guys, my floor is getting really sticky. So it appears that we're going to have to store one of these values within another variable in order to switch these. So one thing that we can do is introduce another variable, and let's call this temp, and temp is empty. Let's create another string. So we'll create string temp, and we can either set this to null, or we can assign no value at all, where we simply just declare temp a variable. So what we're going to do is actually take x and store x, whatever value is in here, within temp. So we are going to type temp equals x. So now x can be filled with something, so we're going to fill it with variable y. So on our next line, we're going to set x to equal y. Then we're going to take our temp variable and store this within y. And lastly, y equals temp. Breaking news, ladies and gentlemen, we have switched the contents of x and y with the help of our variable temp. Now back to you, bro. Thank you for the live update, Anchor Bro. It appears on our end that we have also switched the contents of x and y as well. So, in conclusion, if the programming language you're using doesn't have any direct function to switch two variables, you could do this manually, and you can create another variable such as temp. And temp is a temporary value to temporarily store one of these values. You can set temp to equal x, or you can do this with y, and then set x to equal y, and then y to equal temp. So your assignment for today is to post two variables in the comments down below and the code that you used to swap them. And that, ladies and gentlemen, is how you can swap two variables.
Old Spice Gentleman's Body Wash. 24/7 moisturization with exfoliation.
Shop Michael's lowest prices of the season for up to 60% off thousands of items. Sale ends June 16th.
Hey, how's it going, everybody?
temp equals X. And what was it? Temp equals Y. So main rate. Believe that took me so long. Input 2 equals x equals y, I think I got it. I think.
It's your bro, hope you're doing well, and in this video I'm going to teach you guys how we can accept some user input in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Welcome back, ladies and gentlemen. I'm going to explain how we can use a scanner to accept some user input. The scanner class is found in the Java utility package of your library, and we need to import that before we can use the scanner. So outside of the class, at the top of our program, this is what we're going to type. Import java.util, and the name of the class we would like to import, which is scanner. Then a semicolon. Now we can use the scanner class to create a scanner object. So we're going to be performing a little bit of object-oriented programming.
The frick? Scanner. Okay.
We'll be covering object-oriented programming in a later part of the series, so don't worry. So repeat after me. Scanner, then we need a name for the scanner. Let's call it scanner, all lowercase, equals new scanner. Then a set of parentheses and a semicolon. Within the parentheses, we're going to type
Why is it red?
system.in. And there we go, we have our scanner. So we can use the scanner to accept some user input. So let's let the user know that we would like them to type in something, maybe a name. Let's create a prompt that will ask somebody for their name. So within a print line statement, we'll type, "What is your name?" And next what we'll do is take our user input and assign it to a variable, perhaps a string variable called name. String name equals, and now we're going to use our scanner. So we type in the name of the scanner, dot, and to enter a line of text, we're going to use a certain method of the scanner. It is the next line method. And when we type in user input, we type it into the console window here at the bottom. So let's do something with this name, maybe display this within a message. System.out.println, hello, plus whatever your name is. So let's compile and run this. What is your name? Now our program is currently paused.
Oh, excuse me. Mm,
until we type in some user input and then press the enter key. When you press enter, that's how you submit some user input into the console window. So I'm going to click within my console window and type in something. I'm going to type in bro, and to submit some user input, you press the enter key. And it states hello plus my name, which is what I entered, bro. Now, there's different types of input that we can accept. This time, let's accept only an integer number. Perhaps we can ask somebody for their age. So let's write a prompt for that. System.out.println. How old are you? And this time we will declare an integer variable, maybe called age. Int age equals scanner dot next, and we are looking for int. So we can only accept a whole integer. You are plus age plus years old. Okay, let's try this again. What is your name? Bro, how old are you? Let's just say that I'm 18. Hit enter. Hello, bro. You are 18 years old. So what happens
how old am I? 300. 300 years old.
if we do not enter in a number? So let's try and break this. What is your name? Bro, how old are you? We're not going to enter a number this time. Let's type in the word pizza and see what happens. Well, we encountered an exception. We encountered an input mismatch exception because when our scanner is looking for an integer, we typed in a string. So we need to make sure that the input type, the data type, matches. In a future lesson, we'll be covering exception handling, where we can prevent this very thing from happening. But for now, since we're beginners, we'll just have to be sure to type in the correct data type of the input that our program is looking for. Now, there's one more thing that I want to show you guys. This is a common problem if you use next line after next int or anything else that's not next line. So let's ask somebody for their favorite food this time. So let's add that at the end. System.out.println. What is your favorite food?
Okay.
Then we'll create a string variable called food. String food equals scanner dot next line. And we will display this. System.out.println you like plus food. Alright, so here are the questions. What is your name? Bro. How old are you? 18. Now pay attention to this when I press enter. When we reached the question on what is your favorite food, well, our program skipped our user input and continued on with the rest of the code. So it states, hello bro, you are 18 years old, but we were not able to input anything for our favorite food. Here's the reason why. Here's what's going on. Let's pretend that this box is a representation of our scanner, and we're going to use the next line method of our scanner to read a line of text. So we type in our name and then press the enter key to submit. So this \n is an escape sequence for a new line. The next line method will read an entire line of text and stop when it reaches a new line character. So after we call the next line method, our scanner is going to be empty. However, if we were to call a different method that doesn't read a new line character, such as next int, so we type in our input such as the number 18 and then press the enter key, that will add a new line character. So our next int method is only going to read this numeric portion of our scanner, and then when we submit it, well, this new line character is still going to be within our scanner. And if we were to use our scanner again and call a different method like next line, well, our next line method thinks that we're at the end because there's this new line character within our scanner. So we would need some way to clear out that new line. One easy fix for this is that after you call the next int method, what we could do is call the next line method to clear our scanner. So I'm just going to copy this portion and paste it. We're not really going to do anything with that.
Where do you put it? Oh, other.
New line character, this will just clear the scanner for us. So now we should be able to answer all three questions. So type in your
What the heck? Oh, whoops. This next one instead of next line. Yeah, now it worked.
name. What is your name? It is bro. How old are you? Let's say I'm 18. what is your favorite food? And you can see that it paused this time, unlike the first time. And my favorite food is pizza. Press enter. Hello, bro, you are 18 years old. You like pizza. Well then, that is one way in which you can use a scanner to accept some user input. Scanners are capable of much more. You can also use them to read the contents of a file and a few other things, but we'll learn about those in future videos. And if you need to use a scanner, be sure to include this import at the top. Import java.util.scanner, because the scanner class is found within the utility package, and then you'll need to create a scanner object just by following these steps. Scanner, you can call it scanner, equals new scanner. Well, guys and gals, that is how scanners work in Java. Before you go, I would greatly appreciate it if you could do a favor for me and like this video, leave a comment down below, and subscribe if you'd like to become a fellow bro.
Already subscribed. All right.